Hey guys, welcome back to my channel. Today I'm going to do something a little different than a standard repair. I'm going to be identifying parts and components on the Raspberry Pi 5. Here's the Raspberry Pi 5. I'll go through each individual component, all the chips, all the memory, and all the interface slots. Without further ado, let's get into it. Starting with this black chip at the very top. This is the SRAM. This is essentially the same as your computer's random access memory, or RAM. This is pretty self-explanatory. It's just the system memory. It determines how many tasks the Pi can handle at once, and how well it performs multitasking or memory-intensive applications. Next, we have the processor. This is the main quad-core ARM Cortex-A76 CPU. It currently runs up to 2.4 GHz, and it powers all the computing functions, and it's a massive upgrade in performance over the previous Pi 4. It is the center metal piece here. Next, we have this small metal piece on the top left side. This piece is the dual-band 802.11ac wireless and Bluetooth 5 interface connection. This is built in for Wi-Fi and internet connectivity, and Bluetooth for connecting peripherals like keyboards or mice, or wireless sensors. Next, this small brownish-black bit is the PCI Express interface. It enables high-speed peripherals like NVMe SSDs. Very importantly, we have this white button. This is simply the on-off button. This is actually a first for the Raspberry Pi. It allows safe startup and shutdown without needing to unplug anything. This is a massive upgrade, as no other Raspberry Pi has had an on-off switch. Just next to your on-off button, this black square in the bottom left is the power management IC. It simply distributes and regulates power to different components of the board, ensuring stable operation. This small white piece here is the UART connection. This is a serial communication port, and it's often used to interface with other microcontrollers. This jack right here is the USB-C port. This is self-explanatory. It is the primary power input. It supplies 5 volts to run the board and its peripherals reliably. This small white connector is the RTC battery connector. This allows you to connect a small battery to power the real-time clock. The real-time clock keeps track of time even when the Pi is powered off. These two metal jacks in between these white are 2 micro HDMI ports. It supports up to 2 4K displays at 60 Hz, and allows you to connect the Pi to monitors or TVs for a full desktop experience. At the very top here, we have this black box. This is the Raspberry Pi RP1 I/O controller. It's a custom-made chip for handling USB, camera, and display interfaces. It offloads I/O tasks from the main CPU, improving performance. Up here, this white connector is a fan connector. It's a dedicated 4-pin header for connecting fans or a cooling system, and it supports software-controlled speed regulation. The large USB ports right next to it are simply 2 USB 2.0 ports. It's for low peripherals like keyboards, mice, or microcontrollers. It's slower than the USB 3, but it's still useful. Of course, following that, we have the 2 USB 3.0 ports. These are high-speed ports for external drives, webcams, or data-intensive peripherals. This is great for fast file transfers. This is the Ethernet transceiver. It converts digital signals from the Pi to analog signals over Ethernet. It enables fast, stable, wired internet connections. This is it here. Here, the small 4-pin connector is simply the Power over Ethernet hat connector. It enables power and internet over a single cable. It is this 4-pin right here. Up here. These are simply 2 4-lane MIPI controllers. As you can see, both connections are labeled CAM and DSIP. CSI is used for camera, and DSI is used for display. This supports high-speed video and display data transfer. Finally, at the top is the iconic 40-pin GPIO header. This is where you bring your electronic projects to life, whether it's blinking LEDs, reading sensors, or controlling motors. It also supports I2C, SPI, and UART protocols, giving you flexible options for device communications. This is simply a standard 2x20 pin header, or 40 pins total, that provides a wide array of I/O capabilities. This header has been a staple since the Raspberry Pi B+, and is compatible with a wider range of hats. This is the end of the video. I really hope you enjoyed and learned something new. And if you did, please drop a like and follow down below so that I can continue making these videos. It's a lot of fun, and I hope you come back next time.